you. I think we have a little bit of time left, so if anyone has any questions for our presenters. I have a question then, maybe to start. Had my ears open as I'm hearing a number of presentations, and it sounds like there's a couple places where there are technology needs. You mentioned species identification as something that currently you don't have anything better that's working with people out with binoculars. Other particular areas, or any of you see a technology gap or a need that the community could really fill that would help with the ocean observing?
Well, I've got one, and all the offshore wind projects are being challenged by agencies to do compliance monitoring for bird and bat kills during operations. And this is a real challenge that the UK is struggling with, trying to use remote sensing systems, everything from video capture to vibration sensors when a bird, for example, would strike a blade, to infrared. But the kinds of systems that are being used at this point are very expensive, and if you have to deploy them on every single turbine on a gigawatt offshore wind project, you're talking about a lot of money. So there's digital aerial videography where they're overflying sites and trying to identify species by pattern recognition software. But again, that's weather dependent. So one of the challenges we have is how do you end up detecting a collision event with wildlife at an offshore wind farm?
Any other needs? I'm thinking particularly, Neil, you mentioned sort of this gap between buoys and being able to measure the distance between. Is the solution some sort of persistent autonomous surveillance? Is it AUVs or?
I think that's my hope, that we can use the AUVs to go between them. They are changing. We've got a new French one coming in a couple of weeks, I think, that can go farther over the same period of time. They'll be a lot faster. They can break through the problems that we have with changes in density, where sometimes your glider might not be able to come all the way back to the surface again, so you have to move somewhere else until you find a place where you can get through. And I think the biggest thing is, although everybody's been trying it, they seem to have finally made a reasonable system of rechargeable batteries. Batteries on the gliders have been extremely expensive. So expensive that when we fill them up, it costs us something like $15,000 if we're going to go out there for a couple of, for 3 or 4 months. And of course, the more sensors you put on there, the more expensive the batteries have to be, and the shorter time period you can go out there. They have this new one that supposedly you can recharge 1,000 times. And so not just the batteries, but actually it makes so much easier, we believe, getting ready to go back in the water again. Normally we have to take the whole thing apart, take the batteries out, do a whole bunch of work on reballasting it and all this kind of stuff. And that takes at least a week for each buoy, each battery that you want to put back out. And that's a tough week. It's generally a little bit longer than that. So these, really what you do is you pull them out of the water, you plug it in, and the next day you can throw it back in the water. So I think there are some new changes that are coming around. The new French one's got these advantages, but there are other things that we're now interested in making measurements of that it cannot do yet. For instance, we're starting to put nutrient sensors on the gliders now as well. So nutrients have not been made very often just on ships. Now all of a sudden we're starting to put them on buoys, and very shortly we'll have one on the glider too. So we'll be able to see what they're doing, out on the northeastern shelf, or channel rather. Where that stuff goes through the channel and over to the other locations, we'll be able to go back and forth with the glider and actually see how it gets there.
Mm-hmm. And then just because I know this, we've talked a lot about the Arctic and sort of an interest from a policy standpoint and a legal standpoint. I'm just wondering, from a pure ocean science observation, some of the challenges of doing work in the Arctic. Obviously, there's a lot we don't know, but in terms of getting out and deploying observation systems or doing research, are there particular challenges you see there that really make the work a lot more difficult?
Well, platforms are always a key for scientists. And one of the things we ran into in some of our offshore studies was just getting access to ships. And fishing vessels are often cautious about providing, particularly lobstermen in Maine, their GPS locations. But if we're collecting data, we need to know where they were when that data point was collected. So we were working with the Gulf of Maine Research Institute to try and get onto a lot of lobster fishing vessels in the Gulf of Maine, and that became the sticking point. So we moved in the direction of looking at non-lobster vessels and shipping, ferries, and other commercial vessels were the avenue for us. So in the Arctic, as the transportation stream increases with more vessels using it, having the word get out to the commercial enterprises that research groups would love to have a very small space that doesn't take up much energy or space on the wheelhouse or up on the deck for research equipment. We do need to know where the vessel is at all times, but if we can get that kind of platform, that would give everybody a chance to collect a lot more data in the Arctic.
Might lead well into our next panel. Any other questions for our panelists? In that case, my thanks.